For chapter 7.4, we're again doing hypothesis tests, this time with proportions, but the overall concept remains the same. We're going to look at our sample, and if it's really far out in the tail, past our critical values, we're going to know that we need to reject the null hypothesis. Anytime we're looking at the sampling distribution of proportions, it's going to be the normal distribution. We have to do this check first. So whatever the population proportion is times our sample size, that needs to be greater than or equal to 5. And Q is the complement of P. So if P is 30%, Q is 70%. Okay, and that multiplied by our sample size has to be greater than or equal to 5. So that is our very first check we have to do. And then we're going to follow the same process we have been doing, set up our null and alternative. Our standard deviation looks like this. It might look familiar from the binomial distribution. And so we'll need to use that for our sampling distribution. Let me go through some examples here. So 1 and 2 are pretty similar, and we're going to decide whether the normal sampling distribution can be used. And if it is, then we're going to test the claim about our population proportion at the given significance level. So that's the first step you have to do in all of these types of problems, is determine whether it can actually be used or not. So you're going to do n times p and n times q. So find what your p is. It's 0.22. And so you're just going to do 0.22 times your sample size times 100. That's bigger than 5. And then q is 1 minus whatever p was. So it's 78.78. So do that also times your sample size. And that's also bigger than 5. So we're good to go with using the normal sampling distribution. You're going to state your null and alternative based off the claim, whether it's greater than or less than or not equal to. And then for critical values, we're back in the normal distribution. So use those functions in Excel. So to find the cutoff line for a certain percentage in the tail, here's the functions we use. We enter that percentage, which is alpha. This example is a 2-tail, so I'm going to use that one. Alpha is 0.05, so if I want to split that between the 2 tails, I would do norm.s.inverse 0.05 split between 2 tails, and I'll get my critical value that marks the cutoff line for there being 5% split between the 2 tails. And since there's 2 tails, I need the positive critical value as well, and by symmetry it's the same numbers. And so in between these critical values there's 95%. Outside of them in the tails there is just that 5%. And now to find the test statistic, I just need to look at my sample and see how far away it was from the null hypothesis that we were assuming. And so we can actually go into Excel here to solve this. All the values from the problem are here. We know our null hypothesis is that the population proportion is 0.22. This is what our sample came back as, and we had a sample size of 100. Now Q is 1 minus what our population proportion is stated as, so 1 minus 0.22. And so we can use that information to get the sample standard deviation. We want to use that value of P from our population times Q and then divide by our sample size. So with all that information, we can see how far away our sample was from the null and see whether it's really far in the tails or not. So you take your sample, subtract the null, and then you divide by that standard deviation for the sampling distribution. So that's the value you get. And remember our critical values that went along with this particular alpha of 0.05 for a 2-tailed test were these. So if we got a value even more negative than 1.96, even further into the tail, or more positive than 1.96, we would reject the null. This is safely in between the two, so it's not that unusual of a sample. So we failed to reject the null hypothesis. So 1, 2, and 3 were just like that example I went through. Now looking at 4 here, we're going to do the same steps, but we're going to actually pick the numbers out of a problem. So a medical researcher says that less than 27% of adults in a certain country are smokers. So we have a claim right here, and it doesn't have equality in it, so it's going to be our alternative hypothesis. It's less than 0.27. So we can set up our null and alternative right away. It's going to look like that. This was our claim that less than 0.27 were smokers. And then our Q is always 1 minus what that value is from our hypothesis. So 1 minus 0.27 gives us 0.73. Then let's look at the numbers from our actual sample. Its size is 200, and the proportion from our actual sample is 16.5. So let's put that in. So we have our sample size of 200, and we know our sample came back with a proportion of 16.5%, so write that as a decimal. And we can then do the standard deviation, take the p times the q and divide by the sample size, the square root of that. So now how far away was our sample from the claim? We want to take our sample minus the claim, subtract those proportions, and then divide by that standard deviation. So that tells us how far away we are in terms of standard deviations. And now let's see if, based on our critical values, if we're going to reject the null hypothesis or not. Critical values are going to depend on alpha, so it's 0.05, and we're doing a less than test. So a left-hand tail or less than, we're going to just put 0.05 in here. And when we do that, we get a critical value of right here. So if our test statistic, if our sample came back even further to the left, even farther away than this value, we know that it has an even less than 5% chance of occurring. This is significantly further left than this value. It's even further left. So we know we're even further out in the tail, we're definitely going to reject our null hypothesis here. And I should have done this at the beginning of the problem. You always want to do your p times q, or sorry, your p times n and your q times n to see if they're both bigger than 5. So 0.27 times 200, put an equal sign there. That's bigger than 5. And our q is 0.73 times 200. That's also bigger than 5. Because they're bigger than 5, we know we can count on it being a normal distribution. So we can use what we know here about the normal distribution to find our critical values and then perform the hypothesis test. So 5 and 6 are going to be pretty similar to number 4, an example I just walked through. Set up your null and alternative always to start with. Find Q then based off the null. And pick out the information about your sample from the problem. Use that then to find the standard deviation. And once you have that, you'll be able to calculate how far away your sample was from the null. And finally, you're going to need to always refer to what alpha is and what type of test you're doing to get your critical values. If this is further in the tails than your critical values, then we are way far away from the mean of our distribution. It's very unlikely, and that's when we reject the null hypothesis.